All right, welcome to the after work video. We're gonna keep working on this book. It's important to do. I only have about a half an hour here, but that's perfect. It's important to be consistent. Do a little bit every day over time. If you really can't get it in a day, skip a day. But to be as consistent as possible is the most important, even if you're not consistent in the length or the effort you give. Just carving out that habit is really important to accomplishing things long term. All right, so we're moving on to use case number 2. Are my SD-WAN edge devices behaving as expected? Pain point: you have a sizable SD-WAN deployment, and you are probably tracking and monitoring several metrics from those devices. For example, memory utilization, CPU utilization, and traffic, among others. In the first use case, we have seen how to detect if a particular metric is behaving differently, leveraging time-based anomaly detection. It is about learning normality from the past history of such metric. Sometimes, though, the past may not be enough to obtain the view of normality we need. We have hundreds of SD-WAN devices, and a few of them happen to fail. They must have had some issues we did not know about. The post-mortem analysis shows that their memory utilization was much higher for a long time than the majority of the SD-WAN edges. But we did not know. We had in place time-based anomaly detection, but this only looks at each time series separately, and they had sustained high memory utilization, which the time-based anomaly detection simply learned as normal. So yeah, if you're training your devices in an environment that has not normal behavior where things are going wrong, you're basically training it to see those errors as something that is not unusual. On the other hand, for the most time, the memory was not at a level that triggered any alarm, so it went completely unnoticed. Had we been aware of such memory utilization differences, we could have proactively investigated what was happening with those devices and identified that some issue was happening before this resulted in a service outage. However, there are so many devices and metrics. How could a network engineer spend his time reviewing them all and comparing them? Definitely not possible. Some automated mechanism is necessary to identify these situations and alert them. Approach: the pain point described in this use case, and let's remember what the use case was. The use case was my SD-WAN edge devices behaving as expected. So the pain point described in this use case to determine if your SD-WAN edge devices are behaving as expected is an excellent example of problems that can be addressed utilizing outlier detection algorithms. There is a similarity with the first use case, as both are anomalous behaviors. In the first case, we looked at anomalous behavior in a time series. But now we are not looking at time dimension, but at how peers of an entity, in this case the entity is an SD-WAN edge device, behave concerning a specific metric, memory utilization, and evaluate if any of them is behaving differently than the other ones. This is the principle of birds of a feather flock together. Entities that are supposed to be similar or homogeneous should expose similar behaviors in terms of the metrics we use to monitor them. For the SD-WAN devices, very likely they are all from the same vendor. Let's assume they have the same hardware model and software version, and very likely the branches are very similar. It means there is no fundamental reason why memory utilization, as in our example, should be substantially different from one another. There can always be small differences due to dynamic behaviors, etc. But if there is a substantial difference, an outlier, that may be the symptom we are trying to detect. Therefore, to solve this pain point, we will learn how to implement different outlier detection strategies and algorithms to the memory utilization of our SD-WAN edge devices in our simulated data environment. Input data. For this use case, we will focus on memory utilization and use SANS, which is his simulator, to generate the data we need. One of the metrics SANS generates is mem_utilization, which is generated for every device. We will focus only on the SD-WAN edge devices for the purposes of this exercise. In our network model in SANS, we have a device metric generation policy for SD-WAN devices that looks like the following. Alright, looks good. Here we have two examples of devices. For all EXY with X between 1 through 99, we are applying the first policy in the table that generates a stationary memory metric always between 30 and 35, using a uniform distribution. For some few devices, those where X equals 100, the memory utilization metric looks differently. It has also a stationary behavior, but in this case, the range is higher, between 75 and 80. So these few devices are showing a substantially higher memory utilization, but not yet in the 90 or 95 that might have triggered some static threshold in your network monitoring systems. Given these policies, we will use SANS to generate the data we are interested on, this should say in, by calling the following SANS method parameterized accordingly. So there's going to be a Jupyter notebook associated with this, so let's take a moment here, clean up my bookmarks, and then we'll open VS Code and open Jupyter notebook and follow along. So last video we finished out use case 1, so it's time to move on to use case 2. We see that here, and yeah, so we see we've got 2 Jupyter notebooks here. So let's go ahead and start Jupyter. So the command is just Jupyter space notebook, hit enter, and it'll give us a handy dandy pop-up there to just go right to it. So now we can click number 2, and now we need to know which Jupyter notebook there is. I'll just open both of them, and we'll do like a control F to try to see the so we're looking for metrics for this line, so I'll copy that. I'll come in here and do a control F. All right, and let's see if we got any matches. Okay, so we've got a match here for this one. Now it might be the same, so we've got a match here for this one as well. So we need to know which, so this is extra libraries to install, and then this one is new libraries to install. So we need to know which one to work with. All right, so let's see some differences in the code. So we've got our parameters, time delta. So let's see if that's a difference. Okay, so here's the parameter, time delta. All right, so this is the same. So it looks like we've got some options here for data generation. So if you want to generate new data, then you can run these cells. If you don't want to generate new data, they do have the data already generated and ready to go here in this SD-WAN files here. So the CSV files is the file type. So yeah, I'm not sure which I'm not sure which is which. These kind of look like they're the same. So I don't know what the difference is between these two. Now we see new libraries to install versus extra libraries to install. So, in order to get extra, you have to do the new ones first. So I guess I'm going to start with this one here. Now we will need to make the same modifications here since we're not using Google Colab. So let's do that. We get the benefit of just copying from use case 1, having figured that out. All right, so if we do it like this, now we can delete this whole cell because we're not going to be using it there. So hit the cut button, and now we can change our paths here. So there we go. We're gonna have the root folder be in there, and then we're gonna do like that. So that should do it. We might need to install some more things, but we did install them in the last one. So hopefully this is it. Let's see. So let's do a restart and clear all output. All right, and now let's run each of the cells. Now this is PYOD. I think PYOD was PYOD. Interesting. Yeah, so PYOD is a new one. I don't know if it's a typo and it's meant to be PYDOT. Nope. Okay, so it looks good. So sys is not defined. We need that import statement in there still. All right, so that's looking good. Now here's the moment of truth. Okay, looks good. We didn't even get the warning until now. Now we've got the warning, and it looks like it's a bigger problem here. There's actually no module found named PYOD, and I mean that makes sense because we installed it, but we never imported it. So it looks like there's kind of a typo in this one here. And it looks like, oh, well, you know what? This one has it. This one has that import statement there. But this one has it there as well. So there's no module named, oh, and you know what? It's erroring out here. There's no module named PYOD. So I think the problem is you have to use that, and I can't really explain why. It's just from talking with ChatGPT. So if this works, we'll get a clearer answer for that from ChatGPT. All right, so now run this. That looks good. And now it's the moment of truth. And there we go. So that worked. So let's get an explanation for that from ChatGPT. So what I did is I ran a Jupyter Notebook. I ran Jupyter Notebook, and then I have a notebook file. And then what I did is I used an exclamation point, and then I included the command pip install of a library. So what I did was exclamation point, pip install, and then a library. And that did not work. When I imported that library, it could not find that library. So I solved the issue by, instead of using an exclamation point, using a % sign. So now the new line was % pip install the library. And that worked. So can you explain to me what is happening here? Like, why did it work with a % sign, but not with an exclamation point?
Let's break down the two different methods you tried. Exclamation point. Using an exclamation point in a Jupyter Notebook is a way to run shell commands. When you run pip install less than library greater than, it executes the pip install command in the shell, just like you would if you typed it directly into your terminal.
Yeah, and it's already running, so...
However, Jupyter Notebooks run in a specific Python environment kernel.
Right.
If your notebook kernel is different from the environment where pip installs the package, the installed package might not be available to the notebook kernel.
Yep.
%sign, %, using a %sign, % introduces a Jupyter magic command. Magic commands are special commands in Jupyter that start with percent for line magics or percent for cell magics.
Okay, so this makes sense. Let's keep this brief here. So basically, the idea is if you use an exclamation point, you're interacting with the shell, and you're not necessarily doing things that will load into the Jupyter notebook unless you stop the notebook and then restart it, because once it's started, it pulls from that shell initially to create itself, but then as it's running, it can't interact with that shell anymore. So when you make interactions with the shell using the exclamation point, they aren't by default loaded into the running notebook because it runs on a kernel specific to the notebook that loaded in things once it was created. But if you make modifications not to that kernel, just to the shell where you ran the notebook, then they're not going to be present in the kernel. So instead, you can use the magic method with the percent sign, and now you are interacting with the kernel when you do that. So you're pip installing things directly in the kernel when you use that character. Yeah.
Yes, you bet right. Here's a concise summary of the key points. Exclamation point, interaction with shell, pip install lesson library greater than runs the pip install command in the system shell.
Yeah.
Environment mismatch. The package might not be installed in the Jupyter kernel's environment. Visibility. The installed package may not be immediately visible to the running Jupyter notebook kernel. Workaround. Restarting the notebook might load the newly installed package if it was installed in the right environment.
All right, so yeah, the key idea: installs it in the shell, but not in the running kernel. Installs it in the running kernel. So basically, you pretty much always want to use percent signs because you want, like, most of the time you'll probably want things to apply to the kernel, right?
Yes, exactly. In most cases, you want to use the percent for package installation in Jupyter notebooks.
Okay. All right, that makes sense. All right, so that's the problem. And we're going to work with this multivariate. Well, what are we learning about here? Multivariate, or are we learning about outliers? Oh, okay. So therefore, to solve this pain point, we will learn how to implement different outlier detection strategies. Okay, so we're going to work with both. These are both outlier detection strategies. One is multivariate, and then there's the other one. So I'm not sure which one to look at first. Yeah, I'm not sure which one to look at first. So let's just continue on with the one I've got. Okay, so we're working with the new libraries, and then we'll work with the extra libraries later. So I'm going to restart and clear all output, just because I'm a little bit lost. So I'll start from the beginning, and then I'll run this cell, and now, it looks like I ran, okay, well, it was just marked down, so that's fine. There we go, so that's already installed, and it's installed in the kernel. Paths are perfectly fine. So now all my import statements work. The ones that didn't work are simply just, it worked, but it's giving me a warning saying that it's not optimized. So that's fine. Doesn't have to be optimized. All right, so let's try to get to where the book is. So we've got our vendor, we've got our parameters. So now we need our data frame, but the problem is the module sans has no attribute generate device metric time range. So, right, and this is something I had to troubleshoot and resolve in the last one as well. So if we go here and then we look at yeah, so this is what I did from sans import sans, because it's not a pip installed module. It's a module that exists in the local yeah, so it has to be accessed in a different way here. All right, but now if I run this, we'll probably get that warning again, but that's fine. There we go. And now it did the data frame. So now we've got the cell. Run this cell if you want to load data from the saved file. We don't need to do that. We've got it in our own file, so it should be loaded already. So we can see we should have saved it here. So we probably overwrote the file. So we'll see that as a change to the source control. And you know what? Let's do this. Let's actually make a commit here. So we're gonna undo the modifications to some of these files. Okay, well, let's see here. So we've got mem and CPU utilization. Yeah, you know what? Let's do that. We're gonna undo the modifications. Use case, anything that says use case 2 will undo. Okay, and then we'll go to open another terminal, undo a git status. Okay, and then a git add. Okay, and then another git status. All right, and then we're gonna do a git commit. -m, we'll say use case 1 complete. And this isn't necessarily the best way to do version control, but just trying to get things going here. So git config global user.email. All right, git config global user.name. All right, and now let's do that commit again. Now that it's got the right tracking information, I'll do another git status. So, yep, and then we'll do a git push. Oh, and we're in a branch as well now, so I kind of wasn't doing version control properly, unfortunately. All right, so okay, so let's look at my fork in GitHub. Okay, so we're going to go to repositories, and we're going to go to this one, which is forked. Okay, and now we can see set up local environment. So we'll do compare and pull request. So we'll say use case 1 complete, environment is set up. And say, use case 1 complete. So learned how to set up Jupyter locally, completed entire UC1. Okay, so now I can create the pull request. If I were on a team, people could read the team. People could make comments here. We can see, and then they could grant me approvals, things like that. But I could add reviewers. I could even convert it to draft and spend some more time on it. But yeah, this is all I need. We can see all the files that have changed. So we've got the gitignore file I got from ChatGPT, which is pretty comprehensive. Then we've got all the work I did. You know, I generated these files. I changed the Jupyter notebook, so we should see that reflected there somewhere. Yeah, so here's the .ipynb Jupyter notebook file, and it's a large diff, so it's not rendered by default. Yeah, it's just too large to see there. But anyway, so I'm going to yeah, and then if you're on the team, you can review the changes here, and you can leave comments specifically on certain things. So see this plus sign here. You can click the plus sign and leave a comment on specific lines of the code. All right, but I'm going to merge it in because it looks good to go. So I want to. Oh, and we can see this would be to commit it into the branch where it was forked from. So I don't want to do that. I want to commit it to where I put it. I want to commit it to my fork and not to the original repo. And we can see it wouldn't even work anyway because only those with write access can do that. So okay, so so see here. So yeah, if I click change base, oh, how do I change that actually? I don't want it to commit there. I want it to commit somewhere else. How do I do that? Okay, so if I click edit, I can change the title there, and then I have here I can change down. So let's do a yeah. So we're gonna click main. Yep. So we're gonna do change base. Shoot, but now it's you know what? Let's do this. We're gonna accidentally clicked that, but we're gonna change the base to reflect what's there. So it's going to be like that. Oh, branch is not found. Okay, well, that's interesting. Okay. Oh, you know what? Let's do this. Let's revert it to a draft. Okay, and now as a draft, maybe there's more I can do. All right, and I need a quick break. I'll be right back. All right, I'm back. I don't have a ton of time. I'm not sure what I want to do regarding this issue here. I kind of just want to move on from it and not worry about it because it's oh yeah, you see, so like I didn't create a see I created a pull request for his instead of for mine. So I'm going to close the pull request. And I'll delete the branch. Yeah, see what's happening? I created the wrong a pull request from the wrong repo. I actually kind of am messing with his repo a little bit, which is not good. So yeah, it can get tricky. Version control can be tricky. So if you fork, you need to know that you're still going to be related to the repo where you forked from. So like things will happen like we just saw, where like the default location it will send a PR to is the original repo and not your version of it. So you have to be aware of that. All right, but the good news is we do have everything working up to this data preparation. So let's try these next few cells here. Let's see in the book. So metric df equals sans.generate. Is that as far as we got? Yeah, so that was this one. So data preparation is where we're on now. So let's continue reading. In this case, because we are only interested in the current snapshot of the metric mem_utilization across all SD-WAN edges, we will request only a very short time slot, 4 minutes, which ensures we only get one sample of data per device. The data generated looks like the following table. So this is what metric df will show us. Let's see if we get the same result. Okay, so notebook has changed on disk. Would you like to overwrite the version here or load the version on disk? Reload the page. Let's reload the page. That's okay. We won't have things be saved. There, and it did wipe out everything, but I'm okay with that. Yeah, and we did that intentionally because we made that commit and did not want to. So there's definitely a better way of doing that. This was a very bad way to do that, and we can see I lost all the work I did, but it's pretty easy to get the work back. So I really wasn't that concerned about it. Yeah, so all we gotta do is come here, get rid of this cell, do the import sys, and then put these in there. We don't even need to look at it because we know that it works. Now this is use case 2. Okay, and then everything looks good there. So yeah, now it should work. Oh, and let's actually clear and restart all. Okay, and now the kernel's ready, so let's run everything up to where. So we should get the. I think there was a error. I forget how that error was overcome. Okay, it was overcome by using the magic method rather than the exclamation point. Okay, but everything else is looking great. I remember this. Yeah, so we needed to change the import statement there as well. I knew there was something missing. Oops, and I clicked the wrong thing. There we go. So kernel, restart and clear all. All right, and now that it's clear, let's run things again. Should be a lot better now. Okay, and now we can skip these cells. We don't want to load in. We want to use the one that we generated there. All right, and here's the moment of truth. So now we do get the table that looks like what we see here in this book. The timestamp is the same in all cases. Let's see if that's true. It is. We have 200 observations, one for each SD-WAN device. We will be focusing only on the mem_utilization column, as well as the device_name column that serves as a unique identifier of the device. All the other columns, for now, we will not use them. The data is available in a CSV file, mem_utilization_SD-WAN_metric.csv, so you can load from it or use sans method to generate. So we use the sans method to generate the file. If you use sans, the data may not be identical. Values have a random component when they are generated, but should still follow the same pattern described. A quick visual of the data using a histogram clearly shows that some devices are behaving differently. But let's remember, we are not looking at dashboards or graphs all day, so we need the help of algorithms that will process this data automatically and tell us that something is going on. So here's the histogram. So get down there. Okay, so we've got, so we now just got the relevant columns there trimmed out. Okay, so something else with that, I'm not sure. So timestamp is not relevant in this case. Okay, so we trimmed it down further. We don't need the timestamp. We will focus on memory utilization, on the memory utilization column and the device_name columns. All other columns will be ignored for the moment. All right. Okay, and here's the histogram. Now we've got a few histograms. We've got the memory utilization. We've got one for CPU and memory. So we've got quite a number of histograms there. Let's print out all the histograms. and advance the bookmark. Okay, so we're going to print out all the histograms. There we go. Looking good. They all printed out successfully. Perfect. So now we're at this local outlier factor, and the next part of the book is problem resolution. So this is a great stopping point. I'm out of time. So thanks for watching, and see you in the next one.